morning and welcome back to the basement. Today is new tool day here at the shop and I'm proud to present to you, ta-da! What are we looking at? Well, we're looking at a 1.5 horsepower Delta combination belt and disc sander. So we went from one of the $69 Harbor Freight 4-inch by 36-inch belt and disc sanders, probably a third of a horsepower on its best day. It easily bogs down. This is a 1.5 horsepower Delta motor and much wider belt, 6 inches wide instead of 4, and 48 inches long, so a much bigger sanding platen. This entire surface under here is cast iron and machined flat, so you can put something right on the surface with some pressure and it will flatten whatever you're dropping down here. And then over here we have this nice big basal platen, nice solid cast iron. This thing is a beast. It weighs like nearly 200 pounds. I suppose one thing you can say for the Harbor Freight model is that it's much more portable. But this one, once you get it in place, is just right. And the nice thing about this is it has this fairly accurate scale for the angle. It's pretty easy to adjust. Imagine that I can put a tool at whatever angle and this face will stay nice and consistent and this angle will stay nice and consistent while we're sharpening, cutting, grinding, whatever the case may be. It's a really, really useful tool. I had to clean it up quite a bit. It was pretty rusty. Kind of bought it without knowing if it worked or not, but I figured if nothing else I can find a way to make it work. And as it turns out, it was good to go after I cleaned it up and kind of got it into adjustment and that kind of thing. So, yay for me. New and a super, super useful tool in the shop. Now for the bad news. My General Tools combination square is no longer combined. This is supposed to be on here and slide, and then you tighten this down to adjust it. But it lives on that nail up there, and I knocked it down last night. And it clattered to the floor and broke. So what broke? Well, this little adjustment screw here. It used to be a little longer, and it used to have a little lobe sticking up that rode in that groove. And so when you tightened this thumb wheel, it drew the screw this way, which locked the little lug into this groove and pulled the blade tight into the slot to lock it. So this is just a die-cast metal, pot metal part. I'm sure it is by far the inexpensive way to produce these. A legacy tool, you know, something turn of the century, of course, this would have been made of steel or perhaps brass. So my job today is to make a new one of these to restore our combination square to workable condition. So the first thing to do is to make a drawing, obviously not to scale, but to give me some idea of what I'm looking for. I was able to, there's a few remnants left on here of what this did look like, and I'm able to measure the channel here to get an idea for how deep the lug should be. So if I make the part to these specifications, it may not be perfect to the factory spec, but it'll be a working part. First thing we need to start with is a shaft to the proper diameter and overall length. Then we will thread this end. This is either a metric thread or a fine standard thread. It ought to be standard, but this thing was manufactured in the 90s, so there's no telling it could be metric. And then we will carve away the excess metal to leave that lug there. I've decided to use brass. This is a little part of some kind of a candlestick thing from Goodwill. It ought to be at least as strong as the pot metal and should give us some of the same kind of reduction in friction that the pot metal did give us, where this lug is sliding against the steel. Steel on steel can have a tendency to gall, whereas this brass should give us a nice smooth sliding fit when it's time for it to slide. And center drill it so that we can support the far end on centers. There we go. Alright, So I have stretched it out here to where we got this end in center and that end just clamped up in the 3-jaw. Our overall length is 1.425, something like that. So we just want to make sure that we can get everything we need out of here. So I have my carriage stop installed to keep the carriage from going any closer to the chuck, to make sure that we don't hit the chuck. As they say, clearance is clearance. So I think we are ready to turn. It was about 270 when we started, so I don't have to be super careful with exactly how much I'm taking off on the first pass. 294. Let's do it in basically 2 chunks. We'll take off 25 the first time and 22 or 3, whatever it is, the second time. So now it's at 269. We're going down to 245, so that means we need to take off 24. .245. Here is a 28 thread pitch gauge, and it's a perfect match. So this is in fact a 1/4 inch fine thread, or a 1/4-28 thread. So here is our 1/4-28 National Fine. Okay, so a little quick update here. I have come to realize that I need to make a change to this design, regardless of how it was designed originally. So this configuration has a weak point, which is by applying pressure here, this is going to tend to want to break off right there. But if I will simply redesign it so that the lug piece looks like this, and then you have the force coming this way. By having this base in the channel, it's a lot stronger configuration because it cannot bend. You cannot rotate down the way this one can rotate down and break off. This one can't. You have to shear the brass fully off. So I'm going to change the design of the piece a little bit. And instead of making it look, instead of looking like this, where it just, at the very tip of it is this lug, it's going to look like this, where the shaft extends out past and has a lug part way up the shaft. So in order to do that, I need to finish out the rest of this piece to give me something to work with. With the piece turned down the whole way, we need to do some milling on it. We're going to bolt it down to this 1, 2, 3 block. In order to bolt it down to the 1, 2, 3 block, we're going to use some all thread and turn the all thread down to where it can go through these holes, to where we can have the all thread sticking through. We'll drill through so that the all thread can slide around the piece, and then on the bottom we can tighten, screw down a nut, which will tie the piece to this 1, 2, 3 block. From there, we clamp that in the mill, and we can proceed. So I've turned off just enough threads to where this can slide through these holes. But I have left the threads on this side so that I can put a nut here, and when I tighten the nut, it will suck this piece through, which will suck the piece we're working on down to the bed of the 1, 2, 3 block. So this is some very unconventional, if not downright ugly, work holding. The piece is through there. The pieces of all thread snap. I left just too thin of a wall to try to clamp it down. So we're going with a U-shackle over the top and clamp that down, and that seems to be working. So let's do some milling and see how it goes. So now I've milled away the entire area to the 132 thickness. Now I will drop 50 thousandths more and mill away the 0.525 from that shoulder over to the other side of the bit. Now when I pass that through, that's going to leave that lug 90 thousandths wide. 92 thousandths, which will work. All we have to do now is clean it up, put it back together. If I slide that down in there, it does look like it gets completely out of the way. We have it thin enough. So I'll cut this right here. See if it fits in the groove. It does indeed fit in the groove. So let's put it back together and see if it works. Get this to engage like so. And there you have it. Locks down nice and tight. Sticks out farther here than it used to, but I don't think that's a problem. I think I'll just leave that alone. Voila, my combination square is back in action. And as always, thanks for watching.